problem with the addition and subtraction of two matrices. No? So for the multiplication of two matrices, so first you have to determine if the two are conformable. No? So that means the number of columns on the first matrix should be equal to the number of rows on the second matrix. No? So for example, these two matrices, A and B, so this one is the number of columns on the first matrix, while this one is the number of rows on the second matrix B. So if these two are equal, then these two matrices is said to be conformable, and that means we can perform multiplication of these two matrices. No? So the size of the resulting matrix should now be 3 over 2. Okay, so then to determine the elements of the resulting matrix, so what we will do here, so if, for example, this is your element A, so this should be the result one is located on the first row, first column, so that means we have to consider the elements of the first row and first column of the first and second matrices. So that means we have to have 1 times 6, then plus 8 minus 8 times negative 1, and the result is negative 2. No? So by the way, this is just a recap of what we've done, no? Or discussed during the previous meeting. So I think we'll skip this one. No? So we'll go to the next matrix operation. Okay, so again, this is the matrix multiplication is different from the algebraic multiplication. No? So the matrix multiplication is not commutative. No? So that means if you have x times y, it doesn't mean that you can perform y times x. Okay, simply because it is not commutative. So it has its own rule, no? And that is the conformability rule. The number of columns of the first must be equal to the number of rows of the second matrix. So matrix multiplication is associative and distributive. No? So provided the sequential order should be maintained. Okay? So that means if we have matrix A times matrix B times matrix C, so pwede na tunahon ang matrix AB, then you follow to multiply the matrix C. Or you can also multiply B and C first before you multiply that by matrix A. But again, you have to maintain the sequence. Okay? So if we have this, they have to distribute. Okay? So matrix AB plus matrix AC. All right? Now, if we have a matrix A and you multiply that by a null matrix, so katong null matrix, katong all elements are zeros, no? So if you multiply a matrix by a null matrix and assuming they are, no? The result is always a null matrix. Okay, so murabag na kay matrix A, you multiply it by 0, kanang null matrix mo nag-0 na siya, no? So just in matrix form. The result na is 0. Now, if we have an identity matrix or a unit matrix, no? So I, katong, if you recall, no? So katong elements sa main diagonal, puro siya 1. The rest of the elements are zeros. Then, that's a unit matrix or a null matrix. Oh, sorry. A unit matrix or an identity matrix. So you multiply a matrix, you multiply it by a unit matrix, ang resulta na is equal to the matrix, no? So matrix itself, no? Murag na kay matrix, you multiply it by 1, kaya ng unit matrix that's equivalent to 1, no? Only that it is a matrix form. Okay? So the result is that so A multiplied by unit matrix I, the result is always equal to A. No? Okay, so Now let's proceed to the transpose of a matrix. Now before we go into uh, the other matrix operation, which was the matrix inversion, so katong murag divide bitaw nato, no? So let us first discuss, no, these few items, no? So first, the transpose of a matrix. So the transpose of a matrix is obtained by interchanging its corresponding rows and columns. You simply interchange, okay, the rows and the columns. So the transpose matrix is commonly identified by placing a superscript. You place the superscript T on the symbol of the original matrix. So for example, we have this matrix B, matrix A, for example. So the transpose of the matrix A simply, you have to add or put a superscript, no? Okay, on this symbol of the original matrix A. So this is the transpose of matrix A. Okay. Sorry, it should not be equal. So let's have an example. So suppose we have this matrix B. Okay, and the size is 3 rows, 2 columns. It's 3 by 2, and these are the elements of your matrix B. Now suppose we are required to find the transpose of matrix B. So what shall we do? We simply interchange the rows and columns. So kani karon, for example, kani ang elements atong first row. Let's make that as the elements of the first column. The second row, let's make that the second column. And the third row, let's put that on the third column. Or vice versa, no? These are the elements of your first column. You make that on the elements of your first row. Okay? These are the elements of your second column. You put that on the second row. So simply interchange, no? Okay? So if this is 3 by 2, so the result of the transpose should now be 2 by 3. All right? You simply interchange the rows and the columns. Okay, good. Okay. Now let's go to the inverse of a square matrix. Okay, the inverse of a square matrix A. Suppose you have this matrix A. Okay, is defined as a matrix with elements of such magnitudes that the product of the original matrix A and its inverse, this is the inverse, no, is equal to a unit matrix. Okay, so this is your matrix A, you multiply it by its inverse, ang result na niya is 1 or a unit or identity matrix. So that means kanina yung inverse sa square matrix, mura dahil siya, let's say 1 over A, no? Okay, pero sa matrix operations, ang symbol niya is like this. So you have to put a superscript of negative 1. Okay? So if we have matrix B, you multiply it by its inverse, then the result is 1 or a unit matrix or an identity matrix. Okay? So it's quite simple, no, to check if that matrix A, if a certain matrix is the inverse of a certain matrix, no? Because you simply multiply the two, okay, and if the result is not a unit matrix, then simply that matrix is not the inverse of the original matrix. All right. If the result is a unit matrix, then the two are, or that matrix is the inverse. Okay. So the operation of inversion is defined only for square matrices. So take note, no? So inversion of a matrix is only applicable to square matrices, no? So a 3 by 3 or a 4 by 4, so you can get the inverse, no, of those matrices because they are square matrices. With the inverse of such a matrix also being a square, the resulting inverse should also be a square matrix of the same order. So a 3 by 3 matrix, you can get the inverse of that matrix simply because it's a square matrix, and the resulting inverse of that also be a 3 by 3 matrix. Okay, the same size. Okay, so I hope I made it clear. Okay, now let's have an example. No, so now in this problem, for example, we are required to check whether or not matrix B is the inverse of matrix A. So this is your matrix B and this is your matrix A. So again, to check if this matrix B is the inverse of this, you simply apply the definition of the inverse matrix. No? That is, if we multiply the two, the result should be an identity matrix. If not, then it is not the inverse of this original matrix or the first matrix. So let us multiply. No? So of course we can multiply because they are of the same order. No? So 2 by 2, this is also 2 by 2. That means the same number of rows and the same number of columns of the first matrix to the number of rows the second matrix. Okay, and the resulting matrix should also be 2 by 2, no? The number of rows of the first and the number of columns of the second matrix. Okay, so let us perform the multiplication. So this is your matrix A and this is your matrix B. Okay, the resulting matrix is also 2 by 2, right? So to get the element of the first element, the element of the resulting matrix, no, first row, first column, that means we have to take into account or consideration the elements of the first row, first matrix, and the first column of the second matrix. So it should be 4 times 0.5, that is negative 2, plus 2 times 1.5, and that is 3. No? The result is 1. This one is first row, second column. So it should be first row and .5, that is plus 0.5. This is 0. You continue, the result here is 1. So this is an identity matrix. This is a unit matrix, right? All elements of the main diagonal is 1, no? And the rest are zeros. No? Therefore, this matrix B is the inverse of matrix A. Okay, by the way, I would like to let me stop this. Sorry, my internet connection here is really not good. Madungog na ko ninyo ron? Hello? Okay ra? Loud and clear? Okay, so this time I'm going to teach you using your Excel, no, how to perform this matrix multiplication. No? Let's start with the matrix multiplication. No? So, based on our example, Asam to example na to. So this one, no? So a 3 by 2 matrix, you multiply it by a 2 by 2 matrix. So let's take a picture of this, no? So for example, let us multiply that using Excel. Okay, so example, this is your matrix A, and the size of matrix A is 3 by 2, right? 3 is 1, these are the elements. Okay, 1, 4, negative 5, 4, negative 5, and this one is 8, negative 2, 3. And your matrix B, it's 2 by 2, so 6, negative 1, this one is negative 7, and 2. Okay, so this is based from our example, no, in the previous slide, no? So we discussed that in the previous meeting, no? So these two matrices are conformable, no? So this one, 3 rows, 2 columns. This one is 2 rows and 2 columns. No? So the size of the resulting matrix is also 3 by 2, right? This one, and then this is 3 by 2. This one is 2 by 2. So they are conformable. Number of columns and number of rows equal. That's 2. The size of the resulting matrix is 3 by 2. No? So let us say the resulting matrix is matrix C. Okay, so we expect this, the size should be 3 by 2. No? So to perform multiplication, you simply go to this one, no? Maybe formulas, mathematics, no? Then you go to this one, M mult. Are you still with me? Were you able to follow? So M mult, so array. Remember matrix, they are, it's an array of numbers, no? So matrix 1 or array 1 is 1. Then you go to array number 2, this one. Okay. Then you press Control Shift Enter, no? Control Shift Enter para ang whole elements mo display diha, no? Control Shift Enter. So this is the answer, no? Okay, so negative 2, 9, 20. I think that's the same with our example, no? So okay. So again, you just go to formulas, then math and M mult, matrix multiplications. Okay, so you have here M mult, matrix multiplication. So it's quite easy, no? So you can actually practice ka, no? So let's say another one, let's say 4 by 3 nga matrix. Then another one, it should be 3 by, let's say 3 by 5. So the size of the resulting matrix should be 4 by 5, right? Okay, so kaning 4 by 3, 4 rows and 3 columns. So akong pagbutangan og mga 1, 4, 3, no? Then so this is the first matrix. The other one is 3 by 5. So 3 by 5. Sorry, 3. 3 only. You know? Okay, just an example. No? So this is a 4 by 3 matrix, 4 rows, 3 columns. And this is a 3 by 5 matrix, 3 rows and 5 columns. So again, the two are conformable. No? Number of columns is 3, number of rows here is 3. So they are equal, so they are conformable. We can perform multiplication. The size of the resulting matrix should be 4 by 5. Okay, so 4 by 5 is 1. 4 rows, 5 columns. 4 rows, 5 columns. Okay, so to multiply this one, you have to go to formulas, then math, then M mod. Matrix multiplication, M mod. Okay, you press this one, first matrix, and for the second matrix. Then, what shall we do after? You press Control Shift Enter. Okay, so this is now the resulting matrix, no? The product of these two matrices. Okay, so I would like you to try this, no? So anyway, we have examples, no? So I want you to practice also, no? So you can put numbers, anything here, then you perform matrix multiplication using manual, no? Manual computations. No? Okay, so do you have questions or clarification so far? Any questions? There's a question in the chat box. Assignment ba sir, manual or Excel? No? So of course, manual ginasya, no? But you can of course use Excel to check, no, the result of your correctness of your computations. No? Okay? By the way, nagbutang na ko dari og kaning assignment, no? So nagbutang na tag-assignment sa inyong canvas. Okay? Okay, balik ta dire ha. So again, the inverse of a matrix. So if we multiply the two matrices and the result is unit matrix or one or an identity matrix, then the two are the inverse, no, of the matrix. Okay. So kaniya, if AB is equal to 1 or B is equal to 1, then B is the inverse of A. Consequently, okay, it's also safe to say that your B is also the inverse of your matrix A, or A is the inverse of matrix B. Okay? Okay, now, the next is how to get the inverse of a matrix. Okay, bago man ta nga pag-check ta nga inverse man na siya, you simply multiply, no? Okay, karon saan man nato pagkuha if you have a matrix and you are required to get the inverse. Okay? Siguro okay lang kung board exam kaya na may mga choices, no? You simply select from the choices, then you multiply that from the matrix, and if the result is the unit matrix, then that should be the inverse, no? Pero kung wala, of course, you have to perform yun, no? How to get the inverse. No? So the inverse of a square matrix A is the adjoint. This is also the other definition, no? Is the adjoint of A divided by the determinant of A. Okay? So, bago na po na eh. So, lisod din siya, no? So, katong matrix multiplication, ang let's start sa matrix addition, no? And subtraction, wala yung problema. Sa matrix multiplication, medyo nanay gamay yung problema, no? Kaya na you have to check if the two are conformable, di ba? And what should be the size of the resulting matrix, and of course, to get the elements of the resulting matrix. No? So, medyo complicated na to gamay, no? Pero mas complex pag yun ang ganing pagkuha sa inverse. Okay? So, mo ni ang yung definition, no? The inverse of a matrix A is the adjoint of A. Then you divide that by the determinant of A. Okay? So, let's say you have a matrix A. Okay? Kuhauni mo ang yung inverse, no? So, the inverse of matrix A is the adjoint of matrix A. Okay? So, ang adjoint of matrix A is the matrix of cofactors. So, kanis yan, no? Ako lang na, adjoint. Tanaw lang nako, adjoint. Divide that by the determinant of matrix A. So, karon ato pa ning solbon ang adjoint, kunya, ato po ning solbon ang determinant sa matrix A. Now, unsa man ning adjoint? Ang adjoint sa matrix is the transpose of the matrix of cofactors. Oh, matrix of cofactors pa yun. Okay? Unsa man dyan ang cofactor? The cofactor of an element of a matrix A is defined as the sign minor. So, grabe yan, naghana na. Ang cofactor, sign minor. No? So, minor of the element. Okay? So, it's -1, then raised to the I plus j. So, ith row and jth column. So, it depends on the location of your element. You multiply that by the minor. Okay? So, nagka-complex na siya, no? Anyway, let's have an example later on. No? Okay. Now, ang minor of an element is obtained by evaluating the determinant that results from removing the row and column corresponding to that element. Okay? So, obtained by evaluating the determinant period, no? Resulting from removing the row and column that corresponds to that element. So, you remove. No? Anyway, we're going to have an example later on. No? So, I just would like you to take note of these different terms. No? Then, the determinant is a value associated with the square matrix. It can be computed from the entries of the matrix by a specific arithmetic expression, while other ways to determine its value exist as well. So there are actually a number of ways, no, how to determine the determinant of the matrix. Okay, let's have here some examples. So determine the inverse of this matrix. Okay, so chaon man nato pag, let's say we have a matrix A, and these are the elements of your matrix A. And we are required to determine the inverse. Okay? So, sayon ron dato kung mogamit din ta og Excel, no? Okay, but of course we have to learn unsaon gyud pagkuhaan using manual method, no? So, for me that's the kuan gyud. For a proper, the best, no? You have to learn how to crawl before to walk, no? So in this, again, problem, you are required to find the determinant, the inverse of this matrix A. So let's remember, the inverse of matrix A is equal to the adjoint of matrix A divided by the determinant of matrix A. Okay, so kaning determinant, to sanay siyang solbo, no? So ang pagkuha ng determinant, no? So how to solve the determinant of matrix? Actually, na ay mga daghang bahagi, no? As I mentioned a while ago, no? How to determine the determinant of a matrix. Okay, for 3 by 3 matrix, ang buhaton na niya, there is a simplest form how to get the determinant of that. You simply copy, no, the elements of this first two columns here, 1, 2, 1, -2. I would like you to review, no? So, the kanang textbook about matrix operations on how to kanang solve determinants. Kaya again, as a while ago, as emphasized, there are actually a number of ways, no? For a 3 by 3 matrix mo na yung buhaton, no? Okay? You simply, there's a simple way to determine the determinant, no? So kani, you simply copy the elements of the first two columns and you multiply this, you get the products, no? These downward diagonals. Okay, kani siya. So ang result ni is, this is 1. Now this one is plus 6. Okay, sorry, this is 0, no? Na kani siya is plus 6. This one is 6. So this one is the sum of the products of this downward diagonal. Then you subtract the sum of the products of this time the upward diagonals. Kani siya, no? 1 times 3, that's 1 times 0 times 3, 0. Kani siya is, that's negative 3, and this one is negative 4. Okay? The result is 19. Now, if the determinant is equal to 0, so remember, i-divide na nimog 0, so that means wala mo exist ang iyang inverse. But since this is not equal to 0, that means exist ang iyang inverse. Okay, so okay na ta sa kanang determinant. Okay? So I would like you to, again, as an assignment ninyo, no? Although it's not, you're not required to submit that, but I would like you to study on how to find the determinant of 2 by 2 matrix or 4 by 4 matrix, no? Okay? Maybe up to that point lang siguro, no? A 2 by 2 matrix, it's not actually a problem to get the determinant, no? So kato na mga higher order matrices mo ay medyo puti na sad kaya. Okay na ta sa determinant. So karon is to get the joint. Remember, the joint is the matrix of cofactors. Okay? So it is the transpose of the matrix of cofactors. Okay? So mo ni karon ang atong adjoint, no? You get the cofactor matrix, then you get the transpose. To get the transpose, not a problem. You simply interchange the rows and the columns. Ang karon ang atong ang matrix of cofactors. Okay? Saan man nato pagkuha sa matrix of cofactors. So ang cofactor of the element is the signed minor man siya, no? And you have to eliminate the rows and columns. So, for example, no? Let's go back here. So, this is a 3 by 3 matrix, no? So, ang result nato sa cofactor matrix is also a 3 by 3 matrix, no? So, atong kuha na ang cofactor matrix A. Okay, signed minor na siya, no? So for example, kani siya nga element rin, ana, A, B, C, D, E, F, G, H, I. Okay, so saan man ako karon pag-determine ng yang A, no? So first row, first column, you simply eliminate kani, no? Okay. So then you get the minor of kani. So to get ang minor is the determinant raman na siya. So 2 by 2 matrix ayon na kayo. So it's simply this one. 0 times 1, it is 0. Then minus 1 times negative 3, that is negative 3. So 0 minus 3. So this is equal to 3. But that is the minor. Pero this is assigned minor man. So, ang sign na niya is negative 1 raised to I plus G. So, ako na lang idritso na yun, no? Ang kaning tanang diagonal should be plus. So, kaning siya plus minus alternate siya, no? So, that's how to get the sign. Okay? So, this one is plus, right? This is minus and this is plus. Again, take note that ang main diagonal, ang sign should be positive. So to get this one, A is simply equal to, again, the determinant niya, no? Nabilin. So pila ganito? 0 minus minus 3, so it's positive 3. Ang iyang sign ani niya is positive man, so it is 3. Okay? Ang kaning B is first row, second column. So it should be first row, second column. So eliminate. Kung sa may nabilin karon, kanina lang siya. 2 o 3. So 2 times 1, it is 2. Na kani siya is minus minus 3. That should be 5. Ang sign ani niya is negative, no? So it should be negative 5. Okay? Are you still with me? I believe most of you are baffled with this. I would like you to practice anyway. You can use Excel also. No? So, let's go here. Mauna siya, no? 3. Kani siya is negative 5. Okay? Mauna ang pagkuha karon sa matrix of cofactors. Then you continue, ha? Apakay C. C is located sa C is first row, third column. So first row, kani siya first row, third column. So ang nabilin is kani. So it should be 2 times 1, that's 2, minus 0. So that should be 2. And this is positive. So C is equal to 2. No? So again, kung akong ibalik dire, ano siya, no? 3, negative 5, and 2. Okay? Then you continue. Then you have all these elements, okay, of your cofactor matrix. Then again, the adjoint is simply the inverse, the transpose. So to get the transpose, then you have to interchange, no, the elements of the rows and the columns. So first row, you make that as your first column here to get the transpose. Second row, this one is your second column, third row, and this is your third column. Or vice versa, first column, that should be the elements of your first row. Second column, that should be the elements of your second row. Third column, that should be for the third row. Okay? So now that we have the adjoint of A and we have the determinant, that means we are now ready to solve the inverse, no? Ang mao na ni karon ang atong inverse. So this is the determinant, okay? This is the adjoint, okay? Or the transpose of the matrix of cofactors. Then remember, this is a scalar value or a constant. You simply distribute this, no? Ipang-distribute na nimo sa tanan elements, and that would be the inverse. Well, if you have the result, don't forget, you can easily check this if really this is the inverse by simply multiplying this from the original matrix. And if the result is a unit matrix, then that should be the inverse. Okay? So if we multiply this by the original matrix, the result, this is the result, it's an identity matrix. So therefore, this one, okay, this one is the inverse of this matrix A. Okay, let's check this using Excel. So this is our matrix A. No? So ako na siyang tsuran para ma-utang na to. No? Let's go to Excel. Okay. So our matrix A is 1, 2, 1. This one is negative 2, 0. These are the elements, no? Of your matrix A, 3, negative 3, and 1. Okay, so ang pagkuha na to sa inverse. Ang result, of course, should be the same order, no? And remember, inverse of a matrix should always be applicable to a square matrix, okay? So let's say the inverse of this matrix A is B. So the size is also 3 by 3. So you go there to formulas, math, then this time M inverse. This is M inverse. And where is the array that or the matrix that we have to perform, no, to get the inverse? So butang to nimo, then to get all the elements, no, reflect diha sa imong gi gi sa nga na gi butang diri sa imong Excel, no. So imo tong i-press ang control shift enter. So mao na ni karon, no, ang result. Let us compare this to the one that we perform, no, using the definition katong the adjoint over the determinant. So ako ni siyang i-copy. Copy mo na. Then go back to this one. Mao ni ang result. Kung diri ta, ano, compare ta ni diri ha. So, equal, na? Okay? So, this one is the result using Excel. So, pwede ra mo mag-practice, no? So, you can check your result using Excel. Okay? So, medyo complex ang inverse, no? So, you get the joint. When we say a joint, it's the transpose of the matrix of cofactors. Nalisod ko sa ito pagkuha sa cofactors, no? Okay, so signed minors yan, meaning you have to get the determinant by eliminating the rows and columns that correspond to the row and column of that particular element. Okay. Then of course you get the determinant of the matrix, no? You divide that from the adjoint of the matrix. That's how to get the inverse. Okay, and actually there are other ways, no, to get the inverse of a matrix. And this is just one, I would say, medyo mas sayon-sayon, no? Okay, nga paagi pagkuha sa inverse. Okay, so orthogonal matrix, if the inverse of a matrix is equal to its transpose, then that matrix is referred to as an orthogonal matrix. So that is, this is the inverse and equal to the transpose of the matrix A, then kanisya nga matrix is an orthogonal matrix. Okay? Now this time we have these assignments, no? So I'd like you to perform this manually, of course, but you can of course use the aid of Microsoft Excel, no, to check your solutions or your answers. I think you have to stop here, no? So if you have questions, just feel free to raise them. So I'm going to entertain few questions, no, before we have to leave to one, no, sa kaning meeting. Any questions?
Hello sir, pwede mag-ask regarding the assignment problem 5?
What?
Assignment number 1 kanang sa problem 5 ba sir? Pwede mangutan na.
Yes.
Ang pasabot man na sir na is, for example, natay matrix na A and B. Bare separate raman na sila sir, no? So bali pang itaon na mong inverse sa A and then transpose sa A. Then,
yes. If they are
so,
equal, then they are orthogonal.
Okay sir. Sige sir.
So kani, sayo naman pag-perform ninyo using Excel, di ba? Ang ato lang is katong kuhaon pa ninyo ang mga matrix cofactors, di ba, no? Pero, na, no? So our next meeting will be on Wednesday, no? Next week. So ako na nang gi-post sa Canvas, no? Kaning mga assignments tanan. Ang deadline na will be next week Friday. Okay, any more questions? Clarifications? Woo-hoo.
Sir,
Yes.
Itong with regards itong pagkuha sa determinant sir ba, if kanang example, let's say sir 5 ka columns sir ang naa, so 4 ka columns ang may copy sir, right?
No. Dili na
Or ang duha ra jud
Ano
sir?
siya is only applicable to 3 by 3. No?
Ay okay sir.
So that's why I would like you to to study no on how to get the determinant of especially for higher order matrices. Okay? So 2 by 2 wala problema, 3 by 3 there's an easy way also no, to get the determinant.
Sir, do you have a reference book that you can share for us?
Ini books na lang sa matrices, mahura mo na siya, no? Daghan actually, no? I can't figure out a particular book on matrix kay part naman sa kuna siya, no? Part sa ng mathematics nga kuan. In fact, you have this in algebra, no? Okay. So, pasensya di kayo, no? Na mga times nga hinay ang kuan, internet dire, no? In fact, mo butang sa akong screen nga unstable siya. Kay daghan ko gamit ni Dres Balay. No? Ay online man tanan. No? So, samot ta pud sa office. Okay, so that's all for now, guys. So, hope you've learned something from today's meeting. So, hope to see you all next week, Wednesday. So, we're going to discuss one-dimensional bars. Okay, so basically what we have done so far is just a review of about matrix algebra. Okay, so from especially on the different matrix operations. Okay, that's all, and have a pleasant morning and see you all next week.